David Frame. I'm Dean of the University of Management and Technology. In this program, we're going to take an overview of IT project management. Our goal is to examine project management tools, techniques, precepts in the context of information technology organizations and environments. Now, I'd like to start off by saying that I've been doing IT projects for a long time. I began working actively as a software developer back in the 1960s, and I've been tracking progress of the IT arena since that period of time. And one of the things I've noted in recent years in dealing with people in the IT industry is that there's a constant confusion amongst IT people on software development life cycles and project management. A few years ago, I was dealing with the Chief Information Officer and senior IT professionals at a major Wall Street financial services company, and I was sitting with them around a table doing an interview when the CIO said to me, he says, David, I'd like to ask you a question. Right now we have a big debate, project management debate in our organization, and that is it possible to use multiple software development life cycles to do the work that needs to be done within our organization? Is there some inherent conflict? Should we have one standard software development life cycle? And when he asked me this question, I was actually surprised. And my response to him and to the other executives was, I suppose so. Perhaps several SDLCs would be appropriate, but I said, I'm not quite sure why you're asking that question. I thought we were here to talk about project management. Then now it was the turn of the CIO to be surprised. He said, well, I am. I'm asking you about the software development life cycle. I said, no, you're asking me about the software development life cycle. Project management really is something quite different. And then he asked me to explain, and that's what I'd like to do now, is to explain at the outset that there is a major difference between the software development life cycle, which focuses on the technical steps that one needs to go through if one is going to implement software solutions successfully. And I want to contrast that with project management and the project life cycle. Now, to begin with, be very simple here. The software development life cycle, as I just mentioned, refers to the technical steps that you need to carry out. There are many variants of software development life cycles. Most famous is something called the waterfall model, which basically states that you design solutions, you implement them, you test them, and you're going through a step-by-step sequence of events. And like a waterfall, the water flows down, it doesn't flow back. So it's a step-by-step sequence. You can have spiral software development life cycles. For example, when someone is doing something like rapid prototyping, you start with a high-level design solution, implement a prototype, test it out, go to the next level of detail, implement, test it, and so forth. And in a sense, it's like going through a spiral, starting with the big picture, working your way down to the detail. Again, in both those cases, whether you're talking about a spiral model or a waterfall model, we're focusing on technical issues. We're focusing on things like preliminary design reviews, critical design reviews, architectural reviews. Now with project management, we're concerned with other things. We're concerned, for example, with the budgets. Are we spending money faster than we should be spending it? We're concerned with resources. Do we have the people on board that we need in order to be able to implement our software development life cycle? We deal with a lot of other soft issues, such as politics. Project management is very concerned with politics. Politics are inevitable on projects. So with project management, when we make a decision, even when we implement a particular technical solution, we're concerned with the political aspects of the decision as well as the technical aspects. So in this program that I will be delivering to you, our focus is principally on project management and project life cycles. Now it's all being done within the context of software development and implementing other IT solutions beyond software development. So we will be making reference to the system development life cycle, and we will be talking about the special circumstances that IT professionals encounter. But I want to reiterate, our primary focus is on managing IT projects as projects. Okay, the key words there is projects. So that will be our focus. And one thing you're going to see is that there's a lot in common between managing an IT project and managing a pharmaceutical project and managing a construction project or a defense weapon systems project. You're going to see they have an awful lot in common, even though the technical areas differ between these different fields and all that. They have a lot in common, and most of our attention is going to focus on the common issues. Now let's spend some of our attention on the real basics of project management. Let's define what is a project, and then afterwards, what is project management. So we'll start off with the question, what is a project? And what I'm going to be presenting to you right now is standard fare. Just about everyone who's active in project management agrees more or less that the definition I will be providing you is on target. So let's start off. Okay, one thing about projects is that they are about producing results. Projects are results oriented. In project management, the actual result that is produced, whether it's a good or a service, we call the deliverable. So projects produce deliverables. And it turns out, and common sense would suggest this, that people who gravitate to project management are people who are results-oriented people. Projects are about producing results. People who enjoy doing project work are people who enjoy producing results. And we'll be coming back to that later in this program when we talk about traits of effective project professionals, whether they're a project manager or some other team member serving the project's interests. So project management first is about producing results. Okay, a second feature of the definition of projects is that projects occur within a defined period of time. We like to say that they have defined beginnings and ends, and then within this time period they're actually temporary. When projects are done, they're done. Okay, so a project has a defined start and a defined end, and this has a number of management implications for us. One thing, the fact that you have a defined end date suggests that you're under schedule pressure. You could argue that projects have many milestones. You can argue that the most significant milestone is the delivery date. If you miss that delivery date in today's competitive environment, you may find yourself in big trouble with your customers. So one thing then, when we talk about projects having defined beginnings and ends, this implies from a management perspective that we have to contend with deadlines, schedule issues, and then this can create some substantial pressure for us in doing our project work. Another implication is that if a project has a defined beginning and end, it's temporary, and when the project's done, it's done. Now think about that. You might say, well, when things are done, they are done. What's the big deal here? Well, compare that feature of a project, the feature of a project when it achieves its target date and the deliverable's been delivered, it's done. Compare that with something called processes. The defining characteristic of a process is that it's ongoing. The end date is immaterial. It's not a key element of defining a process. With a process, we carry out the same steps, 1, 2, 3, 1, 2, 3, 1, 2, 3, ongoing until finally the demand for the process has ended. So when we say that projects have a defined beginning and an end, in part what we're trying to do is compare them to processes which are ongoing. And there are differences, substantial differences, on what it takes to manage processes effectively and projects effectively. So let me reiterate then. We've seen that a project, when defining projects, one is it's results oriented, producing deliverables. A second feature is it occurs in a finite period of time with defined beginnings and ends. A third feature is that projects are unique. Every project undertaken in the world today is different from every other project. Now, in some cases, it may be very unique. For example, I worked for a number of years as a contractor with the National Cancer Institute. At NCI, they have a number of Nobel Prize winners in biological and medical sciences. These are very smart people. And they're busily working on basic research, working at the level of molecules and viruses and things like that in order to find cures for cancer. Now, on those projects, you have a very high level of uniqueness. No one has found cures for cancer X or cancer Y or cancer Z, so they're doing state-of-the-art types of research. And in fact, many of these researchers aren't sure what they're going to do on a given day until they come to the laboratory and read the research results from last night. Then what I do today is going to be governed by what happened overnight as my experiment undertook a certain experienced biological and chemical reactions. On the other hand, you have projects that are very similar to each other. For example, building house number 30 in a 50-unit housing development. House number 30, if it's built to the same blueprint, if it's using the same materials, will not be very different as a project from house number 29 or house number 31. But still, even with house number 30, there are elements of uniqueness. For example, house number 30 will be built on a different piece of land than house number 29. If the land is on the bottom of the hill, the builder has to be sensitive to water coming down the hill after a rainstorm and filling a basement with water. So in designing that house, you have to design the land, to contour the land so the water goes around the house. Okay? You also have uniqueness in the work crew. The people who are building house 30 might be quite different team from the people building house number 29. They may be working at the same time. And whenever you start talking about people, now uniqueness issues become pretty dramatic. Because every individual has his or her own set of skills, his or her own work ethic and attitude towards work, his or her own hang-ups and strong points and so forth. So certainly from the point of view of having different work crews working on different houses, you have a degree of uniqueness. And there's a lot of other uniqueness. For example, you may, and these are small things, but house number 30 may have to respond to a new regulation from the county requiring that pipes be a different material be used for the plumbing, for the pipes and the plumbing than we used to use up to house 29. So we have to change our plan to accommodate the new pipes, that kind of a thing. You may have changes in the business climate. Certain materials like plywood. After Hurricane Andrew, plywood became very, very scarce in the United States. Most of the plywood in the U.S. was going down to South Florida to rebuild the cities there. So we can see that House 30 will be different. It is unique in some respects when examined in contrast to the other houses being built in the 50-unit housing development. But the degree of uniqueness is pretty small. I don't want to overstate it. So we have varying degrees of uniqueness. Now, the uniqueness issue has a number of very major implications for the management of projects. One thing is that if every project is unique, what we're saying is that in executing that project, in planning for that project, we cannot depend 100% on past experience, because the past is an imperfect guide to the future. Now that has some implications. For example, if the past is an imperfect guide to the future, this will affect our capacity to make accurate plans. Think about it a moment. All plans are guesses. Every time you make a plan, no matter how good the plan, you're making guesses. Good plans are good guesses, bad plans are bad guesses. One thing that good and bad plans have in common is that they are guesses based on guesswork. Now, to the extent that plans are guesses, it means that when we actually execute a project, what's going to occur will be different in some measure from what we planned. It may be very different, it may be somewhat different, but the point is we're going to find in the implementation of our project that what actually happens is different from what we had planned to happen. That means that we have to be willing to change. We have to adjust the plan in order to accommodate the differences that we're encountering. Okay? Another implication is that to the extent the past is an imperfect guide to the future, it means that we are making decisions at some level of ignorance. Okay, that means when you make decisions with limited information, with some degree of ignorance, you're facing risk. So what we're saying then is the fact that projects are unique guarantees that projects will be filled with some degree of risk. Now, the more unique the project, the higher the risk levels, because the more decisions we're making under conditions of imperfect information and ignorance. So this third feature then of the definition of projects is important and has enormous impacts on what we need to be prepared to do to manage projects effectively. The fourth feature of the definition of projects is that projects are systems. Okay, they are, the dictionary definition of a system says a system is a whole made up of interrelated parts. Okay, that's the dictionary definition, and projects are wholes. They're an entity. There's something that's being carried out comprised of interrelated parts. For example, the tasks are interrelated parts. Now, the fact that projects are systems has management implications. As you all know, that if a piece of a system fails, okay, because systems have all this interconnectedness, if a piece of a system fails, it could very well have ripple effects on other parts of the system. Or if I speed up work on task X, this may have major impacts as to when I can begin work on task B, this kind of a thing. So another thing I want to emphasize, to the extent projects are systems, they have some inherent complexity built into them. Now, I don't want to overstate this. I'm not talking about all projects are very complex, like building a nuclear power plant. That's not my point here. My point is, even a simple project, like preparing for breakfast, if you sat down and tried to diagram in detail the steps that one needs to take to prepare breakfast, you'll see there are lots of parts that have interconnectedness, and it starts looking a little bit complex. So we have with projects inherent degrees of at least some measure of complexity, because they are systems. They have interrelated parts, and when one piece of the system undergoes certain types of experience, this will have impacts on other parts as well. So let me reiterate now this definition of project. So what is a project? Okay, it is something, and some set of activities that produce results. Okay, all projects are goal-oriented. It's something that occurs in a defined period of time with a defined beginning and end. Projects are unique. They are one-of-a-kind undertakings, although they may not be very unique, they're still unique. And finally, projects are systems. They are wholes made up of interrelated parts, and we have to take a systems perspective when we talk about managing projects. So that's what projects are. Whether it's IT project, or construction project, or defense project, that's what projects are. What is project management? Now, I can give you a very boring academic definition, which isn't really going to say much, and let me try that. Okay, project management is the process of carrying out a project in as effective a manner as possible. Okay, so that's one way of defining project management, and it doesn't tell us very much. So let me share with you a much more practical approach to defining project management. A few years ago I did a survey of over 100 project managers, and I asked them to tell me in their own words. I said, tell me in your own words, what is project management to you? And they answered with amazing consistency. 80% said, to me, project management is about getting the job done. And when you think about that answer, you shouldn't be surprised, because we've already seen project management is about producing results, that is, getting the job done, and people who gravitate to project management tend to be results-oriented people. So 80% of my group that I surveyed said, basically, to me, project management is about getting the job done. About half of those people, 40% of the overall sample, roughly, added a caveat. They added a couple more words. They said, to me, project management is about getting the job done on time, within budget, according to specifications. So we hear that answer so frequently, and we've heard it for a long time, that many years ago, I believe in the 1950s, somebody called those three items, okay, getting the job done on time, within budget, according to specs, somebody called them the triple constraints, and the name has stuck with them since that time. So all of our projects operate within the three constraints: the constraints of time, of resource limitations, budget, and also under the constraints of specifications that are established that the deliverable is supposed to satisfy. All projects, without exception, operate under those three constraints. So project management then, to a large extent, is about getting the job done on time, within budget, according to specs. When I discuss this definition with people, every now and then someone says to me, well, gee, that doesn't strike me as a very modern approach to defining project management, because you haven't taken into account customers. And actually, I have. The traditional definition with focusing on the triple constraints does take into account customers. Because if you think about it, the specifications that we're trying to satisfy really have to be oriented to meeting customer needs and wants. Now, if you want to be more explicit, to bring in the customer, to be more customer friendly, you can modify the definition, that's fine. You can say project management is the process of getting the job done on time, within budget, according to specifications, in such a way that leads to customer satisfaction. Okay, so we've seen now at a very high level what projects are and what the project management process basically entails. Let's now take a look at an unfortunate reality of project management. I call it project management's dirty little secret. And that is that most projects experience some measure of failure. The governing law of project management is Murphy's Law. And as you might recollect, Murphy's Law states that if something can go wrong, it will go wrong. I don't know if you're aware of it, but Murphy himself was an actual project manager. There was a man named Captain Edward Murphy, and he worked on Air Force projects on the physiological response of, I think the technical term of the study was the physiological response of very rapid deceleration upon pilots, meaning, I suppose, crashes, whatever. But anyhow, Murphy had carried out a number of experiments, and no matter what he did in order to try to assess the physiological response of rapid deceleration on pilots, the experiment would be messed up in some measure. So he would fix one problem, then another problem would arise, and so on and so forth. So it was, I think, 1949, he wrote up a piece where he described the phenomenon he encountered, and he was talking about it in a serious way, but later on people began joking about Murphy's Law. If something can go wrong, it will go wrong. Now, Murphy's Law is the dominant law of project management, and we all have to recognize that. By saying this, we're not being unduly pessimistic. This is the reality. This isn't an issue of being optimistic, pessimistic, having a cheerful view of the world or a gloomy view. This is the reality. Things constantly go wrong because projects are unique. We already saw that in the definition. Every project's going to have surprises in it because every project's different from every other project. So we have to recognize things go wrong. Now, is there any real evidence, or is this just hearsay? Do we have evidence? And in 1995, a consulting organization called the Standish Group produced a study which shocked those of us who operate in the IT industry. The Standish Group study examined over 8,000 IT projects whose total dollar value was more than $25 billion. And it was examining success and failure, and it came up with the remarkable conclusion, the remarkable finding, that on the IT projects it examined, over or somewhere around 84% experienced some degree of failure. That means only 16% were clear-cut successes. Now, of the 84% that had some measure of failure, 35% were total write-offs, total failure. Okay? The remaining 51% were projects that Standish Group folks said were in recovery. They were in trouble, but they needed work if they were going to be brought back on track. So this is a pretty depressing information when you reflect on it, if in fact it's true. It's saying that only 1 out of 6 projects, basically, 16%, go sailing through the whole project process smoothly, and then 84% encounter some pretty rough waters. So when I first saw these figures, I had trouble believing them. And I decided to do some work on my own to see if I could replicate the kinds of findings the Standish Group study came up with. In the end of 1997, beginning of 1998, I had a chance to work with 437 project professionals in a number of different industries. It wasn't just IT, there were IT folks, but there was also telecommunications, people in retailing, financial services, construction, so pharmaceuticals. So I had a broader spectrum of people I was examining than the Standish Group study, which focused only on IT projects. And I asked these people, I said, on your last project, to what extent did you get the job done within the budget you had for the project? And 55% reported having some degree of cost overrun. So 45% were able to get the job done within budget or even under budget, but more than half had some cost overrun to contend with. Fine. Then I said, okay, on your last project, to what extent were you able to meet your specs? And here the news was much happier. More than 2/3, somewhere around 70%, 69–70% of the respondents said we were able to meet the specifications, and in fact, some of them reported they came in way better than the specs. They produced better products than they were asked to produce. That means then about 30%, somewhere around there, had some difficulty in achieving their specs. But when you think of how bad things could be, the information on specifications is pretty good. Okay, so 70% or so were able to achieve or do better than the specs. Then I came to the third question, the third of the 3 constraints, the triple constraints. I said, on your last project, how did you do from the point of view of meeting your promised schedule? And here things got really pretty bad. More than 2/3 reported having schedule slippage. Of those 2/3, half of the 2/3, meaning 1/3 of the total sample, indicated they had very serious schedule slippage. The 1/3 of the total sample indicated that they had some schedule slippage. It was modest, it wasn't very serious. But the point here is then, of these three constraints, budget, specifications, and time appears to be the killer constraint. And in working with many people in project environments, one thing I hear over and over again, and that is, on my projects, if things start going wrong, I can very often renegotiate budget, and I'm willing, my customers are basically willing to accept some little bit of cost overrun, let's say. Also, if I'm having trouble achieving the specifications, I can renegotiate some of the components of the deliverables we'll be delivering. Okay, but the one thing I cannot renegotiate is the deadline date. And I hear that over and over again across many different industries, not only in IT. So I think these statistics that I came up with they make a lot of sense, and they're making a point. And the point is this, that if you recall, we didn't do too bad, or at least my 437 respondents didn't do too badly in achieving the specs. They did pretty well. 70% were able to achieve the specs. But they had cost overruns and schedule slippages in large measure. So what this tells us is that, yeah, I can meet the specifications if you give me infinite money and infinite time to do the job. So ultimately, we can achieve the specifications. When we say the projects didn't do well, that they had some measure of failure, we're not saying that a deliverable wasn't produced. Ultimately, a deliverable was produced and it met the specs. But the price of producing that deliverable and meeting the specs might be very much this business of cost overruns and schedule slippages. So in carrying out our projects, we have to be aware that Murphy lives, that Murphy's Law is something that we're going to have to contend with. That's a reality that we need to deal with, and that we have to prepare ourselves for things going wrong. Now, it turns out, on a more positive note, that we have a pretty good idea of why things go wrong, and to a large extent, the problems we encounter on our projects reflect the very nature of projects and project management. These problems very often are hardwired into the project. Back in the 80s, I wrote a whole book on this particular topic, and the topic was predicting the inevitable problems we encounter on projects. And I have more recent editions of it, but the book was Managing Projects and Organizations. And the theme of this particular book here is that on our projects, most of the struggles we encounter, by my reckoning, something like 70% are predictable. And they're hardwired into the project management process, and they are basically tied to three sources of problems. The first source, and no one's going to disagree with me on this one when you hear it, the first source of problems is the organizations in which we work. Everyone agrees that organizations seem to put up these obstacles that make it difficult for us to achieve our goals. Now, within the realm of organizational sources of problems, one stands out. It's like has floodlights on it. Okay, it stands out. It's shining. It's blinking, and that is problems tied to something called matrix management. Now, in the United States, something like 85–90% of projects that are carried out use some form of matrix management, whether people are aware of it or not. What is matrix management? Matrix management, very simply, is when you use borrowed resources to do a job. And if you think about it, most of the projects you're carrying out, the people who are actually physically doing the project work are typically borrowed. For example, let's say I'm writing a major management information system upgrade. I have to borrow design people from the design shop. They come in, do some design work, study the old design, reconfigure the new design, and then when they're done with the design work, they go back to their home in the design shop. We need to bring in systems analysts to study the current system, the desired system, to talk to various users and so forth, and put together some sense of what the needs and requirements are that need to be addressed. So we use the systems analysts when they've done their work. They go away, they come back later when we need to deal with them again later on. Now we need people to write the software code to implement the system solutions and the designs. When we've done with the code writers, we send them back to their shops. We need testers to be brought in. The testers are borrowed. They come in, they'll do 2-3 days of testing. When they're done testing and written up the results and suggest various fixes, they go back to their shop again. So on a typical project, this is the way things happen. The work is going to be done by bringing in people from different parts of the organization. Very often today, of course, they're even coming in from outside the organization. It's called outsourcing. So we'll even contract out some of the work, bring in some outsiders to help us achieve some components of our solutions. So when you're dealing with borrowed resources, a little reflection will suggest to you that certain problems are going to be occurring. We have to be prepared to deal with them. For example, from the point of view of the borrowed resources, they're typically not very happy with this whole process. I, as a borrowed resource, have suddenly got a notice that I've got to go help someone test something, and this isn't part of my annual plan. So what this testing job is going to do is it's going to distract me from achieving my performance objectives for the year, and my evaluation will be based on achieving those performance objectives. So that's one issue I have to contend with. This thing is interrupting the work I'm doing right now as I go off. Other complaints of the borrowed resources is they often find that when they're assigned to a job, they're really not qualified to do it. Not because they're incompetent, but because the job itself really needs someone with a different set of skills, and by some accident they were assigned to do it. The job may require a civil engineer. You send a sanitary engineer. We got the engineering part right, but we didn't get the rest of it right. So that's a major complaint. When I get on the site, I find I'm not qualified to do the job. Another predictable complaint is how do I get up to speed? I mean, every time I come on a new assignment, I'm spending about 30% of my life getting up to speed technically, and also getting up to speed organizationally, trying to identify who counts, who doesn't count, where do I fit in the team overall. Probably the most serious complaint of the borrowed resources is that they don't know how they're going to be evaluated. Okay, how do I get evaluated for the work I do? And this is a non-trivial issue, because in theory, evaluations they lie in the power of their functional manager, their boss. Okay, but the boss isn't able to see what they're doing as they're being farmed out doing these different jobs. So to a certain degree, the boss is not qualified to evaluate their performance. Okay, by the same token, project managers are probably not qualified to evaluate their performance also, for a number of reasons. Project managers rarely have the technical insights that a technical specialist has, so it's hard for them to see whether this borrowed resource has done a good technical job. Project managers also, I want to say, the ones that I know, and I'm also referring to myself as a former project manager, we're not interested in getting involved with performance appraisal reviews. We have projects to run. We don't want to get bogged down on evaluating the efforts of the various players who we borrowed to do our job. So the borrowed resources have a lot of concerns when they are assigned to these projects, and this creates serious problems for project managers, because they have a bunch of people now assigned to their project who don't want to be there very often. They may not be very happy about this new assignment. Let's take a look at the complaints of the project manager. We just mentioned one, and that is they're dealing with borrowed resources over whom they have little or no control. Project managers are not bosses in a traditional sense. A boss is somebody who controls resources. Project managers typically don't control the resources. Okay, so if they're going to get things done, they've got to be able to influence people to do things. They can't command them to do it. So I have a bunch of people who are possibly demoralized. How do I do team building? How do I get them to to do what needs to be done when I don't control them and when they're unhappy to begin with. Another major problem of project managers that project managers face under these organizational circumstances of borrowed resources is getting the right number of the right people at the right time. Okay, those are the three major challenges that project managers face: getting the right numbers of the right resources at the right time. The right number means that we want people who are qualified, we have enough people to do the job. Getting the right resources means we want to have qualified people, people who have the skill sets necessary to do the job. And at the right time, that's every bit as important as the other two, even though we tend to ignore it. The right time means that I need those resources when I need them. If you send me Albert Einstein a week earlier than I need Albert, I can't use him. If you send Albert Einstein a week late, once again, I can't use him. I need Albert when I need Albert. So these are the complaints then that project managers have. Predictable struggles that they have in managing in an environment where we have borrowed resources. Functional managers, the bosses of the borrowed resources, also have predictable concerns and complaints about matrix management. One obvious concern is they're losing control over their staff, over the people who work in their shop. Every time you send a technical person out to work on a project team, you really don't know what these people are going through and whether they're doing shortcuts in achieving their technical goals and these kinds of things. Furthermore, as a functional manager, my job is to evaluate these people's performance. And how can I do my job? How can I do my job properly when I don't see them performing? So that's a concern I have. Another typical predictable concern that functional managers encounter is they're constantly getting bombarded for requests for resources. And when they send out the resources, this may mean that they themselves don't have enough resources to do their jobs in their functional area. Furthermore, when people ask for resources, they're always saying, can you send me your best performers? In 30-some years of doing project work, I've never heard the following request. Gee, do you have any deadwood you can send me next Thursday? Nobody wants the deadwood. Everybody wants the high performers. So we can see then that these organizational sources of problems are hardwired into doing project work. To the extent we use borrowed resources, and most projects do use borrowed resources for economic and other reasons, to the extent we have borrowed resources, then we're going to have the kinds of struggles to contend with that I've just described. A second predictable source of problems on projects, and particularly this affects IT projects, probably affects IT projects more than many other types of projects, and that is poor management of needs and requirements. Now, all projects, whether it's construction or pharmaceutical or financial or marketing projects, struggle with trying to identify needs, wants, and then to convert these into requirements. Everybody does. But in IT projects, we have a particular problem, and that is that our deliverables, the things we're dealing with, are largely knowledge-based. They're largely dealing with concepts, with intangibles. Heaven knows it's difficult enough to establish a requirement when you're building a physical structure, a building, but at least it's pretty easy to test to see whether you've achieved the requirement. When you're dealing with knowledge, when you're dealing with intangibles, all these things becomes much trickier. I would say that in the 1990s and into the early 2000s, we recognized that one of the greatest challenges we have in managing IT projects is trying to bridge the gap between our business customers and the technical team. This is a very, very major issue right now. I work with a lot of IT organizations in the financial industry, in the defense industry, and just pure IT organizations in the IT industry. And in every one of the places I'm working with right now, they are struggling to bridge the gap between the business needs of the business customer and then the technical skills and capabilities of the technical team. How do you bridge this gap? The business people don't understand the technology, and typically the technical people don't really understand the business. So you can see right away that on IT projects, right away there's a built-in tendency for miscommunication between these two sets of players. Recently, in the last few years, a whole category of new IT professional has arisen to deal with this problem, to try to bridge the business technology gap. And this new position is called a business analyst. I used to be a systems analyst a long time ago, and my primary concerns were on technical issues. With business analysts, what we're looking for are people who have good technical knowledge. Most business analysts that I've encountered came out of the technical shop, who over the years migrated into the business part of the organization's operations. So they have technical competence, they can understand how to formulate problems technically, and they understand a lot of the technology on the one hand. On the other hand, they also understand the business. So the business analysts are assuming a role of greater and greater importance in developing software systems and IT solutions, and their role on projects is becoming increasingly important as well. So we have then a second predictable source of problems is dealing with needs and requirements. Let me just say one more thing, just to drive home my point. Something as basic in trying to satisfy needs, something as basic as understanding who are our customers is non-trivial. Now, why do we care who the customers are? Because it's their needs and wants we're trying to satisfy. So something as what seems to be so simple as identifying who are the customers often winds up being non-trivial. One thing that we learned in the 1990s as part of the total quality management movement is that customers have to be defined much more broadly than we have traditionally. In IT, back in the 1970s and 80s, to me the customer was the user. Okay, and even here, notice I said the customer was the user. I spoke in the singular. Actually, for almost every system I've ever encountered, there are multiple users. And these users have contending needs and wants. It's not like the user is a monolith with a single view of what the needs and wants are that should be addressed. We have multiple users. But beyond users, there are other customers. To a certain extent, the senior executive who signs the check on the customer side, who pays the bills, they're an important customer. We want to make sure they're happy. The bosses of the users are customers in a sense as well. If the users can't use the systems and offer good solutions, then their bosses are going to be unhappy. My boss is a customer. If I don't make my boss happy, I might not get the kind of support I need to deliver my project successfully. So this whole idea of satisfying the user in the singular is really misleading because we have multiple customers. We should be satisfying customers. Even saying satisfying the customer is misleading. We want to satisfy multiple users, multiple customers, and we have to recognize that this involves a lot of compromise because these customers we're dealing with do have contending needs and wants. And as soon as they see us satisfying one set of needs and wants, one group starts getting unhappy. If you shift to satisfy their needs and wants, another group gets unhappy. So this goes with the territory. This is predictable. This encourages Murphy's Law, as it were, if you think about it. Okay, so let me just reiterate then. One major set of predictable problems is the organization in which we work. A second set of predictable problems is managing needs and requirements. A third set of predictable problems are tied to poor planning and control. And everybody knows that. If I had asked you to sit down and identify the 3 or 4 leading causes of project struggles, I suspect that 80–90% of you would be saying, as part of your list, you'd have poor planning and control. Clearly, if we haven't planned our project efforts effectively, if we haven't sat down and put some time into estimating how long it's going to take to do different tasks, estimating what the costs are, estimating what our resource requirements are, taking these estimates, folding them into an intelligent plan, going through the work involved in planning things carefully. If we don't do that, our projects are foredoomed to have a lot of avoidable struggles. We could have avoided these struggles through good planning. Similarly, if we don't have good control systems in place, where we're tracking actuals versus plan, and when we see gaps between actuals and plan, we're capable to move in there and fix the problems. If we don't have good control systems in place, our projects will be out of control. I'm going to add one more predictable source of problems that's become very big in IT, and it's been something that's been recognized just in very recent times. And again, I think this is something you've all experienced, and that is problems hardwired into projects that are tied to bad estimates, to making promises based on bad estimates, promises that we can't keep. One thing I see over and over again on projects is people promising to do what the laws of nature say is a 10-month job, promising them to do it, promising customers to do the job in 6 months. Okay, or projects that should be a $10 million job, promising to do it for $6 million. Promising to add all these features to the project deliverable that we don't have any idea how we're going to produce them. So I call this problems of estimation, and really I guess it's a problem partially of estimation and problem of promising to do more than can be done. Now why do people engage in this self-destructive behavior? Because if the laws of nature say it's a 10-month job to do the job and you promise 6 months, it can't be done. Even before the work has begun, you have hardwired failure into the project. Not only have you hardwired problems of schedule slippage and so forth, you're also going to have cost overruns. Because as you get in trouble because you haven't been able to meet your promises, you start to panic, you throw in extra people, delays ensue, you have to pay the salaries and so on and so forth. So by promising to do the 10-month job in 6 months, you're hardwiring in not only schedule slippage, but cost overruns as well. And in the final analysis, you're going to have an unhappy customer. So why do we do it? And the answer is competition to a large extent. In order to win jobs, in order to get support from our management, in order to win contracts, we feel compelled very often to promise to do more than can really be done. And we say, well, if we do get the job, we'll figure out, we'll be creative and innovative, we'll figure out how somehow to do the job and have customer satisfaction. I want to point out that's largely wishful thinking. Miracles don't occur. If a job takes 10 months by the laws of nature to carry out and you promise to do it in 6 months, there's not going to be a sudden miracle that will enable you to do the job in 6 months. And one of the major challenges we have today in project management is to spend a lot more attention to coming up with estimates that are realistic. Now, even when you come up with realistic estimates, you may find your sales department trimming those realistic estimates by 20–30% in order to have a more attractive package to give to the customer. So it's not just that we've got to make sure we know how to estimate more effectively, we also have to put into place processes that make sure that the promises that are finally made, the official promises, are on target. Okay, we need to have the estimates, for example, reviewed before any contract is signed to make sure that all these promises we've made can indeed be achieved. Because if they can't be achieved, we've got serious issues. If it's with a contract, you'll have contractual issues. Even if it's not a contract, you're certainly going to have unhappy customers. So in reflection on what we've just said here then, one thing you can count on is Murphy's Law is alive and well. You'll be contending with it probably every day of your projects. Don't get depressed. The important thing is to prepare to take the hits. Be proactive, recognize ahead of time that things go wrong, prepare yourself to make things go right. Learn risk management. Projects are filled with risk, and if you're good at managing risk, you're much better at dealing with things proactively. The alternative is to deal with things reactively, which means you're a firefighter putting out fires, the project's controlling you, you're not controlling the project. So in this session, what I've done is to establish the context in which IT projects are carried out. I began by making an important point that you have to keep reminding yourself day by day, and that is project management is different from managing the system development life cycle. It's not opposed to it. In a sense, you can visualize the technical management and the project management moving in parallel, where the project management is over the technical management. But when you're managing projects, there's much more to do than to make sure that the deliverable is technically perfect. You're also concerned with getting resources. You're concerned with tracking progress. You're spending enormous amounts of time talking to people. You're trying to influence people to do what needs to be done because you don't control these people directly. You're typically operating in an environment where the resources you do have are borrowed, many of whom don't want to be there. So when you take a look at the IT project environment, you see that you've got to focus on a lot more than just things like preliminary design review, critical design review, architectural reviews. There's a lot more to it. Now, what we'll be doing with other sessions in this program on an overview of IT project management is dedicating a whole session to dealing with people issues. What are the competencies that we're looking for in effective project managers? We also want to take a look at project management professionalism. People who get into project management seriously are passionate about it. They're concerned with things like PMP certification. PMP stands for Project Management Professional Certification. More than 50,000 people worldwide right now have PMP certification, and it's nice to have on your resume, and it's also a good process to go through to force yourself to become really up to speed on knowledge competencies of project management. In other sessions, we'll be taking a look at tools and techniques. In IT project management, probably the most important tools and techniques are those that enable us to capture customer needs and requirements and to stipulate them in ways that are going to lead to successful projects. So we'll look at tools and techniques, also tools and techniques in very standard project management areas such as scheduling, with PERT charts and critical path method charts and milestone charts, Gantt charts, and some other techniques. In IT project management, for example, a very popular scheduling technique is something called time-boxed scheduling, where you have to do where you try to do 6 months jobs in 2 months, not by doing a whole bunch of extra work, but by partitioning work into smaller segments. So we'll be looking at those tools and techniques in a future session as well. So by the time we're done with this overview, you should have a very good sense then of the environment for doing IT projects, the qualifications and competencies, capabilities that individuals, you as an individual and your team and your organization must have, and the tools and techniques that you should have some mastery over to increase the likelihood that you can deliver your projects on time, within budget, according to specs, in such a way to lead to maximum customer satisfaction.